Okay, for this part then we're going to have a look at reacting masses, and we're going to look in a little bit more detail at the actual being able to calculate how much of a particular reactant you put into a reaction, so that you can actually work out the amount of product you are going to make. So the first thing we need to do is we need to be able to work out something called the relative formula mass of a particular compound. Okay, so really this sounds really complicated, you know, the relative formula mass, but it's actually really straightforward. The first thing you need to do is you need to have a look at your chemical that you're working the mass out for. So for instance, if you see at the bottom there you've got H2SO4. So this is telling me I've got 2 particles of hydrogen, I've got 1 of sulfur and 4 of oxygen. Now for me to work out the mass of that, all I'd do is I'd look at my periodic table, and each of those chemicals has a mass number. So I'd just take the mass number for each and I would just basically add them all up. Now I know at the bottom it's got 2 lots of 1, which is the hydrogen, and 1 lot of 32, which is the sulfur, and 16 times 4, which is 4 lots of oxygen. However, if you just did it all as just adding it all up, so it'd be 1, add 32, add 16, add 16, add 16, add 16, and the whole thing would equal 98. So any mass that you need to work out, you just break down the equation into the single elements that are in there, then find out the mass and just add them all up. Now when we're talking about the conservation of mass, as I've said to you before, the total mass of the starting materials is always equal to the total mass of the substances produced. So in layman's terms, what that means is whatever goes in has to come out. Okay, and this has been proved over and over again in science. It's called the conservation of mass principle. So as I said, this is because in any reaction no atoms are gained or lost, they are just rearranged. So if you put hydrogen in and oxygen in and join them together, you'd make H2O. Okay, you know how many particles, you'd put 3 in, you'd get 3 out. So possible calculations ask you to predict how much of something is made or needed in a reaction. To do this you need to follow the following steps. First of all, write down the balanced symbol equation. Okay, and then you work out the mass of each substance. Check the total mass of reactants is equal to the total mass of the products. Ignore any products or reactants not mentioned in the question, and you will have a ratio of mass of products to mass of reactants, and then apply the ratio to the question. So let's just have a look at that as an example. So we're looking at calcium carbonate, okay, CaCO3. Now if you heat that up, it produces calcium oxide and carbon dioxide. Okay, so the question might say, how much calcium oxide can be produced from 50 kilograms of calcium carbonate? So the first thing you'd do is you'd write down the equation. You've been given all the information in the question. You know that calcium carbonate is CaCO3. You know that the calcium oxide is CaO, and you know carbon dioxide is CO2. Just double check that that balances first of all, whatever's gone in comes out, and in this case it does. Don't be worried about the little S in brackets there, it just means solid. So now all you need to do is just break that down and work out the mass of each of the particles. Okay, so calcium is 40, carbon is 12, oxygen's 16, so you can see there's 3 lots of 16 there. And then on the other side of the arrow you're doing exactly the same thing again. So what this is saying is that 100 went in and 100 came out, but that's not what the question is asking. The question says how much calcium oxide can be produced from 50 kilograms of calcium carbonate. So you've now got your ratio. 100 went in and 56 of the calcium oxide came out. okay, and that's what we're looking at. It doesn't ask you to talk about the carbon dioxide. You know it's there, but it's not part of the question. So if 100 kilograms of calcium carbonate produces 56 kilograms of calcium oxide, then 1 kilogram of calcium carbonate produces 56 divided by 100 of calcium oxide, and 50 kilograms of calcium carbonate produces 56 divided by 100 times 50. So it means you'd get 28 kilograms of calcium oxide.